Alright guys, so in this video I wanted to talk about the derivatives and antiderivatives of trigonometric functions. So before watching this, you might want to have a background on uh, derivatives and antiderivatives. Um, and and we did this last video. We graphed them all, but now we're just going to be using the graphs to find out what their derivatives look like, and hopefully find some functions that fit those graphs that are the derivatives. And it'll make more sense once I do it. But anyways, let's get started. So we're going to start with sine, the sine function. We're going to save tangent for last because it's a little bit more difficult to find the derivative for that than the other two. But let's start with sine. So this sine is just going to be this light pink. So here, the derivative, I don't know if you can tell, but it is, it's about 1. This graph isn't perfect, obviously, but it's about 1. And this is the value 1. So we would say, if you wanted to find the derivative for this, this is where it would be at first, okay? And keeping in mind that the derivative is really just the slope of the graph. So if the slope right now is 1, right, we're going up by 1 unit for every 1 unit we go right, then we would say that the derivative function, which we're graphing right now, is going to be at the value 1. Okay. And then if we go a little further, we get to here, we see that the slope is kind of just at a 0, right? So we would say, okay, the point 0, right? And then it goes to -1 over here. We're just looking at the slopes. So it goes down 1 for every 1 it goes right. That means that it has a slope of -1, which means that the derivative graph is going to have a point right here. And you might already be able to see that these points are lining up quite nicely with the cosine function. And then over here, we're going to have a 0 slope once again. So we're going to have this point right here. And then once we get to here, we have a slope of +1 again. So we get over here. And then this just repeats and repeats. And this derivative function is actually just going to follow the same pattern that the cosine function does. So we're really just looking at the slopes of the sine function, and then we're graphing that sine function's derivative. We're graphing the sine function's slopes. And it turns out that the sine function's slopes have the same function as the cosine function. Yeah. Okay. So we found out that the sine function, from looking at the graph, this is in no way a proof for why the derivative is cosine. I'm just showing, hopefully giving you a bit of an intuition as to why. But the derivative, so we can write dy over dx, is going to equal cosine of x. Okay. Now let's take a look at the cosine function. The cosine function's in blue, so I'm actually just going to, shouldn't have written that because now I have to get rid of this line just to clean things up. Okay, write it again. Dy over dx is equal to cosine of x. So hopefully you can see from the graph that it is cosine of x. It follows the same pattern as cosine of x. Now let's look at cosine of x. Cosine of x is in the blue right here. At first, we see that it has a slope of just 0. So our derivative function is actually just going to start at this point 0. As we go further along, we get to a point where it's actually just -1. So we reach this point over here. This is -1. Okay. And we can see that if we were to draw a line here, there's not really a function, or like a function that we already have graphed, that follows this as we're going along. But let's keep going and see what happens. So over here, it's going to have a slope of 0 again, so we're going to return back to 0. This function is going to return back to 0. Then we go to +1 again. And it's going to just end up looking like this. Okay, so we can see that it does have sort of a periodic function, just like the other ones, but it doesn't really follow the exact pattern of any of the functions that we already have on the board. However, it does look like it is sort of symmetrical with this sine function. And it turns out that this derivative of the cosine function is really just the negative of this sine function. And if you remember, or if you haven't looked at it yet, we have a video on reflections. If we just did a reflection on this graph, on this pink graph, this light pink graph, if we reflected it, then it would actually match up exactly with this derivative function that we've graphed. So in other words, all we have to do is reflect this function right here for it to overlap with the derivative graph. And the way we reflect is we just put a negative in front. So negative sine of x, right, that's the function of the pink graph, is going to equal the derivative of x for this cosine function. And I should probably write that out. Okay. Let's get rid of this. Okay. So we have the derivative of y with respect to x is just equal to sine of x. Oh, sorry, negative sine of x. Right? It's just going to be that sine function flipped over. Reflected over the x-axis. Okay. Now the tangent function is going to look a little bit different, and it's not going to look anything like any of the graphs that we have on this graph already. But let's see what it looks like first. It may not look like it, but this is actually also a slope of 1. Just my drawing skills are not that great. So this graph would start at positive 1. And then we can see that it actually is approaching a really high number, right? So we can sort of make an arbitrary point over here, even though this is obviously not as high as it needs to be, not as big as it needs to be. We'll just put it up there because the graph is approaching infinity, and we see that the slope is actually approaching this vertical line, and that means, well, in this case, it's approaching a vertical line from a positive number. So it's starting from a smaller positive number, and it's getting bigger and bigger. The slope is getting bigger and bigger and bigger. So we can say that this graph is sort of approaching a really high number, a really big number, this derivative, okay? So we can kind of draw it like this, like it's approaching a really big number, okay? Next, let's look over here. Over here we see that we have a really, really big derivative, right? The slope is really big, and then it's starting to go down a bit, okay? So for this derivative, we can sort of say, okay, it was big over here, it was really big over here, and then now it's getting smaller. And the smallest it's going to get is actually this point right here, this positive 1. So once it's over here, it's going to reach positive 1. And I apologize for my bad drawing skills. But anyways, then it's going to get bigger again, right? The slope's getting bigger again, right? You can see that the slope of this graph is getting bigger and bigger. So then we're going to get this again. And you can see that this is definitely not like any of the graphs that we have currently. But anyways, and then it's just going to follow that same pattern. So it's going to have kind of these parabolas like this. Oh, and I'm not going to make another one because it'll go right through the equations. But you can kind of see it's going to, and I'll draw it smaller. Let's say I'll make a little section for us to draw it smaller. What it would really look like is this. Okay. A bunch of consecutive sort of parabolas. Where the derivative is really big, then it gets small, or it reaches a pretty small number relative, positive 1, and then it's going to get big again. And it turns out that this graph is actually the graph for secant squared of x. Okay. And you might not have heard of secant yet. I think I've done a video on it. I'm not sure, but I'm pretty sure. But what secant is, I'll write it out, secant. That's basically just the reciprocal of cosine, okay? And then we're squaring it, okay? So this is secant squared of x, this graph here. So what you're doing is we're basically taking 1 divided by cosine squared. That's the same thing as saying secant squared of x, because secant is the same thing as 1 over cosine of x. So we can say that the derivative for this is going to equal secant squared of x. Okay, so the derivative of the tangent function is just going to be secant squared of x. And secant squared of x is the same thing as saying 1 over cosine squared of x. Yeah. So we were able to take the derivatives of, or we were sort of able to look at the slopes of these functions on the graphs, and then graph those, and then compare them to functions that we know, or maybe we don't know. Or we're able to compare them to functions that we know have those graphs, and then we were able to find out which functions actually represented the derivatives of those functions. And from that, this is actually pretty useful in calculus. So it's pretty interesting to see what we can do just by graphing it and then looking at the slope of the functions. That pretty much concludes this video. Thank you.